we have quite a few students: Vedant, Santosh, Janani. Welcome, all of you. You can all, like we said in the last class, you can all turn on the videos. Whoever can turn on the videos, who don't have any bandwidth constraints, can turn on the video so that we can see each other while we talk. Prangyal, I remember. Yes, Vedanta, I remember Vedant. You were there in the last class. Santosh, were you there in the last class? Hello, Santosh.
No, sir.
Okay, you're coming. Okay, so can you please turn on the video?
Sir.
Yes, Santosh, you have any difficulty in turning on the video?
No, sir.
So okay, good, good, Santosh. It is always good, to see you and while we discuss. Can you introduce yourself, Santosh? You're in which school and which board and which class?
Sir, 10th standard Sri Ahobilam school, sir.
Oh, you are in 10th standard. Oh, we are going to be covering topics from 12th standard now, Santosh. So, would you be comfortable with that?
Okay,
This is
sir.
meant for 12th standard.
Okay.
So, I think you'll find it very hard. If you're at least in 11th, you can follow to some extent. Even that is difficult. Actually, it's not only for the 12th students. This will be, you can follow. Okay. But we are going to conduct another class for the 11th standard. So you can probably try to join that 11th standard. Okay. So this class may be hard for you. You can be there for some time and see how it goes. Okay. But I have a feeling,
I will
it may
see.
be hard for you. Yeah. Okay. So let's get started. So since we thought that today we are going to cover matrices and determinants, so part of for Tamil Nadu, part of matrices and determinants is already done in 11th. Okay, and the applications of matrices and determinants are covered in the 12th. So for the 11th part, matrix, type of matrices, matrix addition and subtraction, multiplication and transpose. So all these topics, I assume you're comfortable, all of you. If you have any question on those topics, I want to discuss those, I can do that. But I'm assuming that you are comfortable, and if that is the case, we can go to some advanced topics starting from application of matrices and determinants. Vedant and
Yes, sir.
yeah, are you comfortable with the 11th portions?
Yes,
The
sir.
basic matrix addition, subtraction, order of
Yes, sir.
matrix,
I'm
and so
comfortable.
on, types of matrices, addition, multiplication, okay, transpose, these concepts, right? You're
Yeah, sir.
comfortable, right? Okay,
Yes, sir. It's fine.
okay. Ranjal, I hope you have also you are comfortable with those, or you want me to cover any of those topics?
No, sir. I have done that.
You've done that. Very, very good, very good. Okay, so I see one new student, Sharmila. Hi, Sharmila. Good evening.
Hi, sir. Good evening, sir.
Good evening. Can you turn on the video, please? We can, in the class, it's better. We you are able to see each other and communicate better. Uh, unless you have any particular difficulty, you can turn on the video. And also, you please introduce yourself. Did you come for the last class, Sharmila?
Yes, sir.
You were there for the last class. Okay, okay. So, can you please introduce yourself? You are in which class and which school and which board?
I'm state board, sir. I'm from Chengalpattu, sir.
Which class?
I'm 11th standard.
11th standard.
Yes, sir.
Okay, okay. Okay, this class is primarily on the 12th standard. Okay, this is for
Okay, sir.
12th. So you may find it a bit hard, but there is going to be a separate class for 11th. You can be in this class. Okay, there's no harm.
Okay, sir.
But there's going to be a separate class for 11th also. So that will be more useful to you. Okay.
Okay, sir.
Right. So if you find something hard, that's fine because you can cover it up in the 11th class for the 11th students. Okay. So I will ask you a few basic questions just to check, your level of comfort. Can somebody tell what is a symmetric matrix?
Sir,
Raja?
if A is equal to A trans, sir, if A is equal to A transpose, then it is called a symmetric matrix. Is it correct, sir?
Yeah, very good, very good. So does everybody agree? Rajal, Sharmila, Santosh?
Yes, sir.
Okay.
Yes, sir.
And what is a scalar matrix? Rajal, can you try? What is a scalar matrix? Anybody? Sharmila, Vedant,
I don't know, sir.
and Vedant? Okay. Scalar matrix is a scalar multiple of a unit matrix or identity matrix. Okay. And that brings us to the question of what is an identity matrix? So do you all know what is an identity matrix?
Sir, if the diagonal,
Yes, sir.
Yes. Okay. I'm going to share my screen now. Are you all able to see my screen?
Yes, sir.
Okay. Identity matrix. What is an identity matrix? You all said something, right? So how do you define it? The diagonal elements are
Diagonal elements is only one.
1, and the all the other elements are zeros. So this is a identity matrix of third order. Okay. Similarly, if fourth order means you do 1 and then 3 zeros and so on. So the diagonal is going to be 1 and the rest of the elements are zeros. And scalar matrix means instead of 1, it is a scalar multiple, lambda into I, which will be something like lambda 0, 0. And this type of matrix is called a scalar matrix. Okay. And does anybody know what is an orthogonal matrix?
sir, if A inverse is equal to A transpose, then it
Very
is
good.
called orthogonal, or A transpose is equal to I.
Yeah, A transpose equal to A inverse is the correct definition. That is the definition of orthogonal matrix. Okay, very good. And what is a skew symmetric matrix?
If A is equal to minus A transpose,
Yes, A equal to minus A transpose, it is skew symmetric matrix. Okay, and what is a singular matrix? let somebody else answer this time other than Vedant. What is a singular matrix?
Shall I, sir?
Let us give chance to others. Pranjal, do you know what is a singular matrix? Sharmila? Uh,
So determinant is rather than zero.
okay, very good. If the determinant is zero, then it is called singular matrix, not other than zero. If the determinant is zero, then it is singular matrix. If the determinant is other than zero, it is a non-singular matrix. Okay, most of the times you will
Yes, sir.
encounter situations where it has to be a non-singular matrix. Okay, so I take it that matrix multiplication we don't have to go through. You know how to multiply two matrices, right? It is like a scalar product. Okay. So what is the condition for multiplication of two matrices? Let us say
If two matrices,
M1 is of the order A cross A and A B. Okay, A by B. And there is another matrix of the order C by D. What is the condition for M1 into M2 to be defined? What is the condition?
Sir, column is equal to row.
Right. The number of columns in M1 is equal to number of rows in M2. That is B equal to C. Okay. This is a condition for multiplying two matrices. Okay. The number of columns of the first matrix should be equal to the number of rows of the second matrix. And what will be the resultant matrix if you multiply M1 and M2? In this case, where M1 is A by B and M2 is of type C by D, what will be the resultant matrix?
AD, sir.
Okay, AD, A cross D. Okay, very good. For computing determinants, there is an efficient method for 3 by 3 determinants. Okay, it's called Sarah's rule. So, how many of you are aware of that? It is slightly faster to compute and without errors. Okay, because when you compute determinants, it's very error prone. Okay, you have to be very careful about the sign. Okay, so there is a rule that somewhat helps us in determining the three by three determinants. Okay, because that is something that you will encounter very frequently in your problems. 3 by 3 matrix is what you will get very frequently. Okay. So, do you know this rule? Vedanta should know. It is there in your book, right?
yes, sir, but I forgot now.
Okay. Okay. It's very important. Okay, to remember that. Prajjal, have you come across this?
No, sir.
Okay. I'll tell you. It'll be very useful. Suppose it is A11, A12, A13, A21, A22, A23, A31, A32, A33. This is a matrix. The determinant of you have to calculate the determinant, let us say. Then what you do, you just write it like this, and then once again you write A11, A21, A31. The first column you write here. Okay. And then the second column you write here. Okay. Now what you do, you take the product of these three. A11, 22, 33, 12, 23, 31, 1, 3, 2, 1, 3, 2. Product of these three coming from top to bottom. Okay. Take the sum of this. Okay. This, and then do another summing like this. Okay. Okay. So this way of calculation will be less error prone. Okay, the same calculation only, but in normal calculation, what you do, A11 into A22 into A33 minus A23 into A32, then you have to check whether second column it has to be minus, no, row 1 second is then minus A12, and then like that. So the sign, it is like, very likely that you may miss some, plus or minus, then everything will go wrong. Okay. In this approach, it's less error prone. So you can remember this method. Okay. Because many times you will encounter finding out the determinant of 3 by 3 order. So maybe I'll give a small exercise. You could just try to calculate the determinant value. Let's see. Shall we just calculate this value? You can calculate it in your own way, and also using this rule, and see whether, which you find easier. Okay. So let's do this. I'm doing this because this is a very, each and every problem, this calculating determinant value of, 3 by 3, you'll encounter very frequently. Okay. Let's do this. So when you're done, please tell me.
Sir, 0.
You're getting 0. Okay. Let's wait for other people. Prajal, Sharmila, please, and who is the other person? Ramakrishna is there, Santosh is there. Yeah, Ramakrishna, you are from 12th or which? Can you please introduce yourself? Which school and which board? Ramakrishna, are you there? Okay. So I think Vedant got an answer of 0. And has anybody,
0,
if
sir.
you're working, you're also getting 0. Okay. Prajnal. So it should be correct then. Okay. Jabahar. Okay. Yeah. So according to the method that I just now told, it will be you have to add 147 258. Okay, and multiply like this. The plus ones are these. 5 nines are 45. Then 12 sevens are 84. 196. 7 5 35 into 3 105. 8 6 48. 9 4 72. So 6 4 10. 1 9 10 18 22. First class. Okay, so the answer is 0. Okay, so this I wanted to tell you in terms of concept. Then coming to the 12th portion now, and more advanced topics. Do you know what is a minor? We have to know about minor, cofactor, and adjoint of a matrix. Okay, so what is the minor? Minor of an element. Let us see this matrix. Okay, so A11, A12, A13, and I'll write it again. This is a given matrix. Now, minor means it's a determinant of a lower order. This is 3 by 3 matrix, right? So the minor will be a determinant of 2 by 2 matrix. Okay. So if you take element A11, its minor will be defined by the 2 by 2 matrix, this matrix, which you get after removing the row and the column that contains that particular element. Okay, if you remove that row and that column, what you get is this 2 by 2 matrix, right? This determinant, this is the minor of element A11. Okay, similarly, you can calculate minor for each and every element. All you have to do is remove the corresponding row and column, and then you will get a determinant of lower order, and you compute that determinant, that is the minor of that particular element. Okay. Next is cofactor. So, what is cofactor of an element? Of an element assigned to it, plus or minus. Okay. The one, it is actually minus 1 to the power of m plus n. Okay. So if you are calculating minor for A11, m11. Cofactor, let us say A11 equal to minus 1 to the power of 1 plus 1. It will be the same as m11. Whereas if you take A21, cofactor of element 21,
Minus.
it will be minus. Okay, so you calculate minor for all the elements, and you prepare a matrix of all the minors, then that is called the minor matrix. Similarly, then you put appropriate signs like this, then it becomes a cofactor matrix. Okay. And then adjoint. Adjoint of a matrix is defined as the transpose of the cofactor. We write it as ADJ. A means adjoint of A. Okay. So adjoint of A is a matrix. Okay. So how do you construct that? First, you calculate minor for each and every element. You form the minor matrix. The appropriate signs you put based on this formula minus 1 to the power of I plus j. Then you do a transpose of the cofactor matrix. You get adjoint matrix, adj A. Okay. Okay. And then inverse. Inverse is defined as 1 by A to adj. Okay. So conversely, you get adj A equal to A inverse into determinant of A. Okay. So these are all I think you would have read in your books, right? You would have been taught all these, correct? All of you?
Yes.
I'm just revising those. Okay.
Yes.
Okay, good. Now let's come to the properties of determinants. Okay. That is what is very, very important. That is what, in terms of concepts, this is where a lot of questions will come. Okay, some of the problems you have to use the properties of determinants, properties of these inverses, properties of the adjoints, to solve most problems. Okay, so I will go through some of the properties. What is the determinant of A inverse in terms of determinant of A? If you know, you can tell me. Properties of inverses, let us say. I want A inverse determinant of A inverse. I have the determinant of A. Now, how can I compute determinant of A inverse? It's simply 1 by determinant of A. Determinant of A inverse is simply reciprocal of determinant of A. Okay. Then let's see. We want to find out what is the inverse of a transpose matrix. We have a
A
matrix.
power minus transpose. A power minus transpose.
Yeah, it is A inverse transpose. Suppose we know A inverse and you transpose that, and that is same as A transpose and so this order is commuted. So instead of first doing transpose and invert, you can do inverse and then transpose. So the result is going to be the same. Okay. Let me see this one. How many get it? This okay. There is a matrix A. Okay, you want to invert a matrix lambda A. What will you get? How will you calculate this? Lambda A whole inverse. Does anybody know? So you inverse lambda, what will happen? 1 by lambda, right? Inverse A,
1 by
you
lambda into A
1
inverse.
by lambda into A inverse. That's all. Some of them look very intuitive, you can easily say. For example, the first one also, okay, inverse of, determinant of A inverse is 1 by determinant of A. So these are very intuitive. Okay. Then Determinant of, let's say, one more question. Determinant of lambda A. Say matrix A, and you multiply, you compute lambda A, means you multiply each element by lambda. Okay, and now we want to find out the determinant of lambda A in terms of determinant of A. What will that be? It's actually lambda power n into determinant of A. Okay, because in the properties of determinants, you can take out the common factor for each row. Okay, for example, lambda a11, lambda a12, lambda a13, and then suppose it is like this. If you want to calculate this you can, this is equivalent to lambda into this is same as this, equivalent to this. So if just one row you can take out, then it becomes lambda. So lambda A means you are multiplying all the rows, all the elements actually by lambda. That means for each row you take out, it becomes you take one lambda out. So you take out as many times as there are number of rows. That is why it becomes lambda to the power of n into determinant of A. Okay, these properties are very important because problems will be given like that. Simplify. If the very complex expression will be given, you need to apply these rules. Now let's see. Here, one more question. Let's see. There is a product AB for which we need to take inverse. Does anybody know what is AB whole?
B inverse into A inverse.
Very good. Okay. Then let's see. A inverse whole inverse.
A.
Okay. This is also very intuitive. Okay. Now let me ask something. Suppose you invert adj, then what will you get?
Adj of A inverse.
Adj of A inverse, correct. And which will be in terms of determinant of A. In terms of A, how can you express it?
1 by determinant of A into A.
Okay, adj of very good. So everybody follow? Everybody understand? All these properties you have to remember. Okay, so you have to understand so how it is coming. Then only you can remember, right? So now let me put one more thing. Determinant of adj in terms of determinant of A.
Determinant of A power n minus 1.
Okay. Determinant of A to the. Are all these covered in your books? I know that it is there in the Tamil Nadu syllabus. They're all explained now. But are they given in your books, Prajal and others? Sharmila is state board only. There is no issue. And other people. So everybody, do you have these books? Formulas explained in your respective books. I'm just recapitulating and putting down those formulas. Okay. Does everybody uh, encountered that in your books before, or now only you are hearing about this? Praja, Pranjal, have you? Is it there in your book? Have you already read these formulas? Sharmila is in
Sir,
11th,
I
right?
can't.
So you. Sorry, what did he say, Pranjal?
Sir, your screen is not visible.
My screen it was visible. Is it visible to others?
Yes, sir. Now I.
Now you can see. Okay. Okay. So I was asking all these properties that I'm writing. Have you already studied them? Is it there in your book and is it already taught in your class, or are you seeing these for the first time?
Sir, it was already in my textbook, sir.
It's there in your book and okay. It's covered in your classes, right?
Yes, sir. I've just prepared the previous month these
Mm,
formulas.
yeah.
So
Yeah. It's
syllabus will
important to
be there.
remember these because in JEE, a lot of questions will, one or two questions in matrices will be there. So they will be on, properties of these matrices. Okay, asking you to evaluate some expression involving edge, inverse, transpose, and all that. Okay, so you have to be very thorough with these formulas. Okay. And yeah, I was asking, Pranjal, is it there in your book? And is it because you're in Maharashtra syllabus? I don't know whether it is there in your book. That's why I'm asking you. I can't hear you. Are you speaking, Pranjal? You're muted.
No, sir.
Okay. What about other? I'm seeing a new people, few new people. Jawahar, Rakshan, Ramkrishna, Sharmila we saw. Santosh we saw. Jawahar, you are in what? 11th or 12th? Jawahar?
Sir, I'm 12th, sir.
You are in 12th. Which school, which board?
Sir, CBSE, sir.
You are in CBSE. Okay.
Yes,
So have you studied these formulas before? Is it already taught in your school, these properties?
yes, sir.
Yes, very good. Very good. Fine. Rakshan. Uh, can you please introduce yourself? Rakshan Ramakrishna. Okay, I don't know if they are there or not. Okay. Let me go to a few more properties. These are very important. Okay. Determinant of J equal to determinant of A into n minus 1 to the power of n minus 1. Okay. Now, what is edge of J?
Determinant A power n minus 2 into A.
Okay. It's a matrix. Edge of J is a matrix. So this is a value, determinant of A to the power n minus 2. So this is a constant into A. Okay. And what is this? determinant of edge of Aj.
Determinant of A to the power n minus 1 the whole square.
Very good. Because if you put Aj equal to some B, and so this is determinant of Aj B, so which is a determinant of Aj to the power of n minus 1, so which is determinant of A to the power of n minus 1 power n minus 1. So now I'm asking you one more. Edge of. Just extending that to one more level. What will this be?
So whether it comes cube.
Yes, it does. Okay. The same logic. Okay. Okay. So this whole thing you can put as some another matrix B. Okay. So and then you can see. So this is edge of B, where B is this. So edge of B is B determinant of B to the power of n minus 1, right? So but determinant of B is, we have this determinant of A to the power of n minus 1 whole square. So again to the power of n minus 1. So it becomes and what is adjoint of lambda A?
Lambda power n minus 1
Into
edge of
edge A. Okay. Okay. So some there might, I don't know if I covered all the required properties. Some of them I think I've covered. Some of them I may have left out. When we encounter some problems, we will learn those if there are anything that has missed out. Okay. Edge of A whole transpose is edge of A transpose. Okay. So on. Okay. Then one more thing. So if edge is given, adjoint of a matrix is given, do you know how to determine the matrix itself? Suppose edge A is given, okay, equal to something like this. And they're asking you, find out what is A. Can you do that?
Yes, sir.
How?
Sir, we have one formula, the plus or minus 1 by root of determinant edge of A into edge of edge A.
Okay. Very good. And that is for n equal to 3, okay? So not for n equal to, they are given a problem n equal to 2. We have to remember that, okay? If n equal to 3, whatever formula you said is right, okay? So what will that be for n equal to 2? That square root will not be there, okay? Because the square root comes because it comes from this, okay? So Aj is given, and we need to get A, right? you use the property. Edge of Aj A equal to determinant of A to, sorry, determinant of A power n minus 2 into A. We saw that, right? Edge of Aj A equal to determinant of A to the power of n minus 2 into A. Okay. So therefore, A equal to 1 by determinant of A to the power of n minus 2, okay, into edge of edge. So if edge is given, you take another edge, then you divide it by determinant of A to the power of n minus 2. But now, what is the relation between determinant of A and determinant of edge A? Because edge A is given, you can easily determine determinant of edge A. The relation between determinant of A and determinant of edge A, there is another, we saw that, right? Determinant of edge A equal to determinant of A to the power of n minus 1. Okay. So if the n is 2, in the case of n equal to 3, it will become determinant of A whole square. So then determinant of A will be square root of. If n equal to 3, determinant of J equal to determinant of A square. That means determinant of A will be equal to plus or minus square root of determinant of J. If n equal to 2, this will be different. Okay. N equal to 2, determinant of J is equal to determinant of A. Okay. So therefore your formula will be A equal to 1 by determinant of A to the power of n minus 2. In this case, it will be determinant of A will be same as determinant of J. Okay. So you can substitute and then you can. So you basically you derive everything from these rules that we have seen. Okay. For the special case of n equal to 3, there are some special formulas given in your book. You can use that. But if n equal to 2 or n equal to 4, then you have to use these basic properties. Okay. Okay. So far for some of these concepts. So when you now we'll try to apply these in real problems, then your understanding will become much better. Okay. So if you just keep on talking like rules like this, okay, the learning will not be complete. So for that, let's look at Tamil Nadu syllabus, the objective questions. I want to look at those problems first. Okay, a few problems from that we will work out. Okay, so then you can, I'm going to ask you to continue with the remaining problems as homework. That only if you practice, then you will really get a grasp of all these rules. It's very important if you're really aiming for JEE. These rules you should be very thorough. Okay, these are the type of problems that you will encounter. But first, we'll go through the Tamil Nadu syllabus, Tamil Nadu book, the objective type questions, and maybe later I will give some problems from JEE itself. Okay, let me look at one problem. First problem. It's okay. If fudge of fudge, 1 minute. Equal to a to the power of 9. what is the order of A? That is the question. Okay, so now you try to apply all that you have learned, all these rules, and can you try to solve this? Everybody, please try. Okay. And when somebody is done, you can let me know. You can raise your hand. Very good. Vedant. Let's wait for other people. Pranjal, Jawahar, Sharmila. Is there anybody else? Ramakrishnan, right? Ramakrishna, Rakshan, there are, yeah, quite a few people. All other people able to do? Pranjal, Rakshan. So what is the formula that is applicable here? Determinant of Hg, I'll just write the relevant formula, then you can write. Determinant of Hg of Hj equal to determinant of A to the power of n minus 1 whole square. Right? I said if it is determinant of Hj, it is determinant of A to the power of n minus 1. It is Hg of Hj, it is n minus 1 whole square. If Hg of Hj, it's n minus 1 whole cube. Okay. We discussed all that. So this is the formula here. So now can you determine the value of n? Everybody should try. Okay.
Sir, n is equal to 4.
You're getting n equal to 4. Okay. Vedanta, what did you get?
Sir, n is equal to 4.
N equal to 4. Okay. Prajal, you want to leave? Okay. Okay, fine. Okay. Very good. So you can, that's okay, Prajal, that's okay. But make sure that, you revise these concepts. I did not see you participate much. Okay. So you have to come better prepared and participate. Try to do these problems. Okay. Now what you see from here is, det A to the power of 9 equal to det A to the power of n minus 1 whole square. So which means that n minus 1 whole square is 9 or n minus 1 is 3 or n equal to 4. Very good. Let's do one more problem. A second problem, okay? In your exercise 1.8. A is a 3 into 3 matrix. Such that A transpose equal to A transpose A. And B equal to A transpose, A inverse A transpose. Now you have to determine B into B transpose. What is B into B transpose? There are four options. A, B, I, B transpose. A, B, I, 3, B transpose. Which of the option is, there are four options. Okay, these are four options. Okay, A, B, I, and B transpose. Which option is correct? B, B transpose, please evaluate. Anybody has got it? So all you have to do is, substitute for B. We want to calculate B, B transpose, right? And B is given. So substitute, B in terms of A. Okay. And then use the properties given to rearrange, readjust, and try to get it to one of the four values given here. What I'm saying is B, B transpose is equal to B is what? A inverse A transpose, right? And then B transpose is what? A inverse A transpose whole transpose. Okay. Now keep on, apply the rules that we know. Okay. So A inverse is it like AB whole transpose? It's what? AB whole transpose.
B transpose into A transpose.
Very good. So just substitute like that. B transpose into A transpose. And next you substitute what is A transpose whole transpose. A transpose is A, right? transpose, and again you put transpose it back, you convert rows to column and again convert column to rows, then it will become the original matrix, right? You transpose it 2 times, it will become the original matrix itself. So this is simply A. Now you look at what they are given. A transpose A is given as is equal to A transpose. So you can substitute that. And what is A inverse into A?
I.
Very good. I. Okay. And A transpose into A inverse transpose. We can write it as A transpose
A
inverse.
power 0.
A transpose, A inverse transpose we already discussed. Yeah, A inverse of transpose of inverse is same as inverse of transpose. A inverse transpose is same as A transpose inverse. Okay. So now you see what is A transpose into A transpose inverse. So given as 3 by 3 matrix, right? So I can put it as I3. And what is this? You just put A transpose equal to some B, no? So this is B into B inverse. Just like the A inverse into A, this is B into B inverse, right? So what is B into B inverse? The matrix into its own inverse.
1.
Again, it is I only. Okay. So I into I is what? This also we saw some time back. You multiply a unit matrix with another unit matrix of the same order, you are going to get the same unit matrix. Okay. So the answer is I3, which is your one of the options there. Okay. I'll do one more problem in this. Okay. So after that, I'm going to request you to continue with the remaining problems. You do those problems in your book. I hope you have your book has got these problems. I'm referring to the same book, right? 1.8. Is it there in your books, the Tamil Nadu book?
Yes, sir.
Right. So doing these problems, when you do, if you are not able to do, you should go and read, okay, the corresponding concepts, corresponding text and examples, then come back and do. That is the way you really learn, okay? So let me do the next problem here. A equal to 3512. Your problem number 3, right? A equal to 3512. B equal to Aj and C equal to 3A. Now you calculate determinant of HB by determinant of C. There are some options given. 1 by 3, 1 by 9, 1 by 4. One. Again, this all applying all our rules that you have learned. You should be able to do this. Now just let's write down the formulas that we saw. Um, what is determinant of edge B? Whereas B is J, therefore I can write it as determinant of edge of J. And what is determinant of edge of J? Determinant A to the power of n minus 1, right? In this case, n is 1. Yeah, sorry, n is 2. So n minus 1 will be 1. So the numerator in this case is going to be same as determinant of A. Okay. You can calculate that very easily. 3 into 2 minus 5 into 1, which is 1. But this may not be needed. Let's see. Okay. Similarly, you calculate what is determinant of C. What is determinant of 3A? So the entire A you multiply by 3. So for each row you take out 1 3. So that means I explained that also. It is 3 power n. In this case n equal to 2 into determinant of A. Right? So determinant of HB is equal to determinant of A. Determinant of C equal to 9 times determinant of A. Therefore, the ratio will be one by 9, right? Ratio will be determinant of A divided by 9 determinant of A, right? Which is that A will get cancelled out. So you get 1 by 9. Okay, if it's not getting cancelled out, you have to calculate the value of data from the given matrix, but that's not needed. In this case, that is not needed. Okay, so what I'm going to do, the remaining problems are all very good in your book. Okay, so they all make you understand the concepts and these rules, by practicing. Okay, so what you need to do is go through the remaining problems. When you don't get the answer easily, or you don't know, you go back, look at the properties, look at some examples, then come back, and then you should be able to do, in that way you please continue and complete this entire exercise. Okay, there are I think some 20 odd problems, not very difficult if you, but that is going to help you to understand all these properties and solving problems based on the properties of determinants. Okay, because we're not going to having the time to do each one of them in the problem, but if you do them and come, and wherever you are having difficulty, those problems we can discuss in the next class. Okay, is that okay, everybody?
Fine, sir.
Right. I think can we continue for some more, because I want to do some problems from CBSE and some problems of calculation also. Just the concepts is what you have seen so far. Can we continue for some more time?
Yes, sir.
Right. Okay. So let me take one problem where we do some calculation. I'm going back to your exercise 1.1. Okay, just to give you some practice. Or I said CBSE, right? Let's go to CBSE. So, 1 minute. We'll go to CBSE. So this problem is there very similar to what we saw. Um, if A is an invertible matrix of order 2, then determinant of A inverse equal to, this is A inverse, not A minus 1, A inverse. Okay. Determinant of A inverse equal to what is the question. Okay. The options are det A 1 by det A 1, det A 1 by det A 1, 0. So which option do you think is correct?
Is this related to formula 1 by determinant of A?
Yes. Yeah. We saw that, right? Determinant of A inverse is equal to 1 by determinant of A. Okay. It's a determinant. Yeah. It is relating to a formula only. Okay. Let's see one more problem. CBSE. Okay, there are some conceptual problems. Yeah, let's look at this. I think conceptual problems are this is in your CBSE book. Okay. Okay. A matrix is both symmetric and skew symmetric. Then what do you think is that matrix? What can that be? Can it be a diagonal matrix, a zero matrix, square matrix, or none of these?
So zero matrix.
Yeah, it has to be a zero matrix because if it is symmetric, A equal to A transpose. If it is skew symmetric, A equal to minus of A transpose. So it turns out that A is equal to minus A. Okay, so that means it has to be a zero matrix. Let me take some more problems from CBSE. Three 3.2. Let's look at this problem. Okay. A trust fund has 30,000 rupees that must be invested in two different types of bond. The first bond pays 5% interest per year and second bond pays 7% interest per year. Using matrix multiplication, determine how to divide 30,000 among the two types of bonds. If the trust fund must obtain an annual total interest of either one scenario is 1,800 rupees, another scenario is 2,000 rupees. So this is a practical application of your concepts in matrices. So you have to formulate this problem and solve it using matrix multiplication. I'm going to allow you to try for some time, think about it, and before helping with that. Rakshan, Vedant, are you able to formulate the problem?
No, sir, I can't get any idea.
Okay. I think we have Ramkrishna also in the class. Ramkrishna, Rakshan. Okay. So let's see there are two types of bonds. Okay. So in one type of bond, you invest an amount investment in first type, first bond. Let us say is X. Okay. So 30,000 must be invested in two. That means investment in the second bond will be balanced, right? Okay. First bond, if you put X amount, the second bond you have to put 30,000 minus X. So that you can put it as a row matrix. This is your investment matrix. Okay. Now the interest matrix you can put it as a column matrix. First one pays 5%. Second one pays 7%. Okay. So you put the investment as a row matrix and the returns, okay, interest rate as the column matrix, and you do the multiplication of the two. Okay, so you're going to get the returns. Okay, the total return that we want is 1,800 in one case and 2,000 in another case. So here the return is total interest. Let's say the total interest, okay, equal to X into 5% plus 30,000 X minus X into 7% equal to 1,800. So that is the equation that you form and you solve for X from this. Okay. The second case, the same thing is equal to 2000 and you can solve for x. Okay. So basically 5x. Okay. So 5 by 100, right? 5% is 5 by 100 x plus 30,000 minus x into 7 by 100 equal to 1800. That means I'm multiplying by 100. You get 5x plus 30,000. Sorry, into 7, right? So 7 into 30,000 is 210,000. 210,000 minus 7x. Okay. I'm multiplying all the terms by 100. So it comes like that. So basically that means 2x equal to, I'm taking, this is minus 2x, I'm taking, to the right side. I get 2x equal to 210 minus 180, 30,000. That means x equal to 15,000. Okay, so you have to invest 15,000 in one fund and 15,000 in the other fund. Okay. Similarly, the second problem will be the same equation. Instead of 1800, you put 2100, right? 2000. 5 by 100 into x plus 30,000 minus x into 7 by 100 equal to 2000. And solve for x now. $200,000 it will become when you multiply by 100. Okay. So that means here 2x equal to 10,000. So you put 5,000 in the first fund and 25,000 in the second fund to get a return of 2,000. Okay. So this is where you practically formulate problems. You would have seen in your book, if the investment amounts and interests are given, the investment matrix into the interest matrix will give the return matrix. So that is the concept that you have to apply here. Okay, so then let's do one more computation problem, and then I think we can wrap up today. So I want to do. There are many problems that.
So much for the answer.
Sorry.
So one minute, please show me the answers in your screen. Yeah, okay, sir. Yeah, thank you, sir.
The first case x is 15,000, second case x is 5,000. $1.1, let's say 1.1 is 1.1. Find the inverse. Let's say, let's do this problem. Okay. -2, 4, 1, -3. This is from your book. Okay. So I want you to practice. This is also very important. Find the inverse. Practice. Find the inverse. I'm taking a very simple problem, but there are other problems, many problems in your book. -2, 4, 1, -3. Okay. So can you do this problem?
Yes, sir.
Yeah. You did it with Vedant. Very good. Rakshan. So the way I would suggest is, in order not to make a mistake, so the minor matrix, you write down step by step. Don't try to, skip steps and do it, mentally and all. So mostly you will do correct, but still sometimes, you may make mistake. So I prefer to do it, step by step. So minor matrix is very easy to put in this case, simply put cut a particular row and column and you write down the other element. So that's very straightforward. You cannot make mistake in this. Okay. This is a minor matrix. Then your adjoint, the cofactor matrix, we write it as A, okay, or cofactor, I'll write as cofactor matrix. So cofactor matrix is simply putting the signs, okay. So this 1, 1 and 2, 2, the signs don't change. But the other 1, 2 and 2, 1, the signs will change. So you write like that, cofactor matrix. Next you put adjoint. Is a transpose of this. Okay, cofactor transposed is your adjoint. Okay, and what is determinant? Let's say this is matrix A. Then what is det A? Det A you can either calculate 2 minus 2 into minus 3 minus 1, right? So that means 6 minus 4, that is equal to 2. Or in a case of 3 by 3, in this case it's very easy, but in the case of 3 by 3, instead of calculating, if you have done this step, you can simply take any row and its corresponding cofactor row and do the multiplication. Minus 2 into minus 3, 4 into minus 1. So that will give you 6 minus 4, which is 2. The dot product of any row and its corresponding cofactor row. You can take this also, 1 minus 3 and minus 4 minus 2. Or any column also. If there is any 0, all the more better. Choose that row, it will be easier for you. So because if you have calculated matrix and, the minor and cofactor, then you can use that to calculate the determinant more easily. Okay. Okay, anyway, now the determinant is 2. Therefore, inverse is adjoint divided by the determinant. So, minus 3 by 2, minus 2, minus 1 by 2, minus 1. This is your inverse. Did you get this, Vedant?
Yes, sir.
Okay. And then let's practice one more problem. So given the adjoint, let us find out A. Okay. So we did one problem like that. There's one problem in your book. Okay. Let's find out A inverse from adjoint. Okay. Slide.